Now let's consider an example where we're taking samples from a population that is not normally distributed, in which case we need to make sure that we're taking samples that are larger than 30. In other words, we need to make sure we're sampling more than 30. In this case, we're taking random samples of 40. So that would be in line with our central limit theorem, which says that, yeah, we need to make sure that we're taking samples of bigger than 30 when we don't have normally distributed data. So here, yeah, x equals the CEO salaries in thousands, where x is skewed right, so it's not normal, with a mean of 139 and a standard deviation of 45. Oops. So here, let's imagine that that mean, wherever it is, maybe somewhere around here, is the mean of our population. And here, because we're taking sample of 40 CEOs, we'll have n equals 40. So this, the sample means are going to be normally distributed, right? Because we have sample size that's bigger than 30, where the mean is the same as the population. And here our standard deviation of our sample means would be equal to the standard deviation of the population divided by the square root of our sample size. So we had 45 was the standard deviation of the population. Sample size was n equals 40, so we'll divide by the square root of 40. And what is the probability that the mean salary of a sample of 40 CEOs is between $137,000 and $145,000? So here we're asking what's the probability that x bar is between 137 and 145, right? Because here we're talking about the mean salary. So that means we're looking at x bar, the distribution of x bar, right? And we're taking a sample of 40, so we can use the sampling distribution that we have above here. So we know it'll be 139 for the mean, same as our population mean. And our standard deviation is 45 over the square root of 40, whatever that is. And so we can use here normal CDF. With the lower at 137, the upper at 145, the mean was 139, and the standard deviation, which was 45 over the square root of 40. So we can just put it all into our normal CDF formula there, right? So in this case, I think we can imagine here we're finding the area of this region between 137 on this side and 145 on this side. Okay. So when we compute this normal CDF formula, we get something around 0.411. So about 0.411 probability that the mean salary of 40 CEOs is somewhere between 137 and 145,000. Continuing with the example from the previous slide, where we're given a sample of 40 CEO salaries, at what mean salary does the top 10% of the CEOs begin at? So in other words, what would be the value of x bar here that would correspond to having an area of 0.10 above it, right? So the top 10% means that you have 10% of the area above it. So here we're going to use the inverse norm, because here we're given the area where we want an area of 0.10. Here the mean was the same as it was in the previous example, right? 139 for the mean. The standard deviation, remember here we're taking a sample of 40, so we'll take the standard deviation was 45 over the square root of 40. And here we're taking the area to the right of that value of x bar. Or, in my calculator, because it only does the left, I would compute this a little bit differently. Since I have an area of 0.10 to the right of x bar, we're going to have a 90% of the area below it. Right, so we know the area below would be 0.90, even though here to the right has an area of 0.10. Below it, right, we're looking at the area below that particular x bar would be the rest of the area, so it would be 0.90. So the way I'll compute it here is I'll do 0.90, 139, 45 over the square root of 40, so all that stuff, same mean and standard deviation as before, but now I'm going to do to the left. Right? In my case, I don't have the option of choosing left or right. It'll always compute the left area. Okay, so my area to the left would be 0.90, the mean of 139, standard deviation of 45 over the square root of 40. And that would give me a value for x bar equal to 148.11. So that would be the x bar here. That represents the mean salary that would split the top 10% of CEOs. So any CEO that makes more than $148,000 is going to be in the top 10% of salaries. What is the probability that the mean salary of a sample of 40 CEOs is less than $120,000? Is this unusual? So again, here we're taking a sample of 40 CEOs. So we're going to do the same sampling distribution as before in the previous parts. But now we're asking what's the probability that x bar is less than 120,000. So here we'll do normal CDF. The lower will be negative 1E99. The upper 120. The mean was 139 and the standard deviation was 45 over the square root of 40. Okay, so here again we have the same standard deviation, or sorry, same mean as the population. So 120 maybe is going to be somewhat farther away because we have a smaller standard deviation than the mean, or than the population. So my guess is that this is going to be a fairly small probability. And let's see what we get when we compute it. For me, it gives me something around 0.0037. And this is a very small probability, so this is, yes, this is unusual. So So yes, it is unusual. And typically, anything that's less than 5% is generally a good, safe bet that it would be considered unusual.